Alrighty, everybody, welcome back to Check-In. Our next team up is 3940 Cybertooth. They're from Kokomo, Indiana. Welcome back, guys. Good to see you. Can you guys introduce yourselves for the people at home?
Hi, I'm Gus Duvall. I'm team president.
And I'm Lucy Baker, and I am a freshman this year.
Cool. Well, welcome to the show again. Good to see you all.
Yeah.
So let's get started. Let's talk about all the cool things you guys have been up to. So first off, let's get an update. We saw some video in there. Tell us how you guys are doing as far as building the robots concerned. Where I know that we saw some looks like some maybe prototypes, maybe production stuff. What's up? What's going on?
Well, we're kind of gearing in on the stage where we are finalizing all of our designs, getting everything CAD'd. So pretty much all of our subsystems have taken shape, and we know what we want from them. It's really all a matter of getting parts built for our first practice bot right now.
Oh wow, cool. All right. So you're going to build your practice bot first, then build your competition robot after that one's done?
Yep, that's the plan.
Yeah, we're doing a lot of manufacturing right now where we're actually making two of everything, so that way we can, we're making the practice bot first, but we also have a jump start to making our real one.
Okay, so you only have to change the parts that are different, basically.
Yeah.
Yep.
Okay, cool. All right, so let's talk a little bit about that then. So you mentioned that your mechanism is starting to look like, looks solid. So what is what are some of the parts of your robot look like? We know that the shooter has been a kind of a question mark so far this season. It looks like you guys have a more solid idea. So tell us a little bit about that.
With our shooter right now, we're looking at, obviously with our turret, we want to be able to shoot from different angles on the field. And so we had to solve the problem of a very small hood and super high RPM for shooting straight up. And so we're working on getting the wrap so that we have enough to shoot the ball directly up and get it into the boiler right in front of it. And we think we found a way to do that by basically feeding the ball up under the wheel and then back out rather than just straight up into the flywheel.
Oh, okay. So it's coming like at the bottom of the wheel and making like 180 degrees worth of, or well, not quite 180, but maybe like at least 90 degrees of wrap around the outside.
Yep, that's the plan.
Yeah, we had some issues before because we were planning on doing it over, but the way that the geometry worked out, we would have only had like 10 degrees of wrap, which would not have been enough at all.
So, no, I don't think so.
Yeah.
let's talk a little bit about that. You guys mentioned to us before the show started that you guys have been working through all the bumps in the road that comes with any sort of big project or build season. Why don't you guys tell us a little bit about those?
A big problem that we had right off the bat after getting some of our prototyping done was just issues with CAD, making things. Our intake has really taken shape on our robot in CAD, and that looks really good. And initially that didn't fit, but we got it to, and so it's going to be pretty cool.
I mean, we definitely had a lot of spatial issues just figuring out what gets more space, and we've prioritized that fuel gets a lot of more space, but a lot of the teams had to cut back on what they had, especially, I know Gears, each time we make something new, we have to cut back and have more restrictions, but we're making it work, yeah.
Cool. Yeah, it's always a challenge to figure out exactly how everybody's system is going to come together. I know we saw some of your prototypes that were not some of your stuff going on there. It all looked really, really tiny. Is that kind of the feeling you're getting this season, that the robots are going to be teeny tiny robots compared to previous years?
Hopefully small, but well designated with space.
Yes.
We're working on consolidating or using up all of the space above our over the bumper intake to get those extra balls and stuff. So our robot looks pretty tiny in prototyping, but reality, we've got probably 30 plus balls stored in our intake at any time.
Oh wow, very cool.
Yeah, it's pretty big.
Nice. That's awesome. Cool. So we saw a little bit of footage of that, of you guys building and actually constructing some of the robot. And Lucy, you were just saying that you guys are like in the middle of the heavy manufacturing process. Why don't you tell us a little bit what that's like for your team? What kind of resources do you guys have available? Is it mostly sending out sheet metal parts, or do you guys machine parts at your shop, or do you guys like just have a drill press and a bandsaw? How does it all work for you guys?
Well, we're machining a lot right now, especially the drivetrain, and they're just making all the pieces right now, mostly on our lathe and mill, but also on saws and different presses, and also people are just creating things by hand, like working on motors, different things like that.
And we've also got an in-house router here at Andy Mark that we get our parts run on there to get the general outline of the parts, but then doing some of the more specific holes we do on the mill and stuff.
Nice. Is it like a big sheet router, or how big's the bed on it? Like really big, or?
I'm not sure the exact dimensions, but it's pretty large. We can get a big robot run out of each time we run it.
Very cool. Mm-hmm. Sounds fun. All right, cool. So let's talk a little bit about as we go into this. We've talked, again, like I said before, we've talked a lot about physical robot stuff. We haven't talked so much about the ones and zeros. So tell us what you guys' plan is as far as controls are concerned. Doing anything cool, doing vision stuff? What kind of sensors are you guys using on your robot? Let's go into that a little bit.
Well, right now we've got a programming team of about 6 people. A lot of them are new this year, and so they're kind of learning as they're going, but they're doing a really great job of working on vision for the turret on our robot, if we can pull that off. So we're working with some pixie cams to try and track the goal. That's going pretty well. We've also looked at pixie cams for a gear auto, as well as the basic encoders and sim coders for shooter and drivetrain.
Yeah, we're doing a lot of, they're actually using our old last year's practice bot, and so they're working with that to do things like counting how many balls are in the shooter and accuracy, different things like that.
Yeah, and then also our controls subgroup is meeting with the rest of the subgroups to talk to them and see what kind of sensors they need to integrate into their code for when we get the final robot done. Because this is really the first year that we've had the programming team be able to work on stuff like this early. So it's been really nice.
Awesome. Yeah, that's always a hard one. So do you guys, I guess maybe this is a mixture of both perhaps, but do you guys come with the philosophy that the programming team dictates what sensors the mechanical team has to implement, or does the mechanical team sort of drive the sensor usage that the programming team has to sort of make work?
It's really the controls team, like the programming and electrical, that decide on sensors, and then they communicate with the mechanical what kind of sensors would be best for the mechanisms they're using. So the controls team are really the ones that decide that. Okay,
cool. I mean, that makes a certain amount of sense. You got to make sure that the people who are going to be doing the code know what's up and make sure the right stuff is used. Okay, that makes sense. Cool. So a lot of encoders, a lot of vision stuff. How's that been working for you guys? I know you guys said you're going to use it. Is it looking promising so far, or is it still in the early stages?
It's still in the early stages, but it does look promising.
Okay, both.
Yeah, they're making progress pretty fast on the vision tracking, so it's going well.
Yeah, we're in a really happy place on where we are, because in previous years we just haven't had this much of a start at this time of the season. So yeah, we're very happy.
So I got to ask, what do you think's made that possible? What have you guys done differently this season to give you more time with the programming?
Well, some of the prototyping that we've done, we got it done right away, as well as also using last year's practice bot to test things, because we already had all the talents set up on there, so they were able to just get a jump start and test the sim coders and other sensors on it. So we didn't have to wait till we had the actual practice bot to test the things that could be done on any robot.
Okay.
Also, our lead mentor, who's in charge of software, he was working on before making a camp for the kids who are new to programming this year, so that way they had an idea going into the build season of what they were going to be doing.
Oh, okay. So you trained everybody up before the season began, so you weren't starting from zero when it was time to start actually building the robot.
Yeah.
Cool. That's a really good idea. I know it's something that my team, we always try to do, but it never seems like it's enough, especially because the build season's so hectic sometimes, but it's great to hear you guys are doing that. So you guys were talking about how you guys have 2 robots. You're starting to build parts for both these robots at the same time, and especially because you're gonna maybe have some of those parts become obsolete when you revise your practice robot. How are you guys tracking all of that? Do you guys have like any sort of system that you use to make sure that the right parts are in the right place?
Yeah, actually this year we kind of developed a new parts numbering system for our team based off of our 2015 parts numbering system. And so basically we're keeping very close track of each part that is manufactured, by whom it's manufactured, and where it's at, like in the shop. We've got a specifically designated area for machined parts and parts that will go on the robot. And so we're keeping everything very, very organized in our Google spreadsheet as well as in our shop.
Oh, cool. That's awesome.
Mhm.
That's I might nerd out a little bit about this because that is like literally my job. I do document control for a living, so that's kind of really good to hear. And is this born out of some problems you found last year? Because you mentioned 2015 you used the system and you're using it this year. What happened last year that made you want to use it again?
I don't think we had a whole bunch of problems last year with it. It's just we found that it was a lot easier to talk to judges and show them what was up with our robot in 2015 when we had that. And last year we didn't really get a good get-go from the start on the part tracking. And so it's good to have it started earlier this year.
Oh, okay. Cool. That makes a lot of sense. Nice.
It also helps like to identify different parts. Like if you have two pieces that are really similar in size, and that way you can be able to distinguish them, or even from spare parts that people just have leaving around. So yeah.
Yes, I can't tell you how many times I've seen what looks like an innocuous washer or just a piece of junk on the table, and I've thrown it away, and someone's like, "No, that's my part."
Yeah. Yep.
So I assume you guys do like write the number on each physical piece as well, so you don't lose it.
Mm-hmm.
Cool. All right. Well, that's very good control of your material. That's good to hear. So let's also talk about something that maybe not a lot of teams are thinking about because it's so early in the season. But let's talk a little bit about scouting. You guys wanted to talk to us about this year. So do you guys have a scouting plan, or how's that all going to work? How are you guys? So by the way, for those who maybe don't know, scouting refers to basically at competitions getting data or observations on other robots, so you know who you're playing up against and who you're going to be picking. So tell us a little bit about your scouting plan this year.
So we've got two very experienced scouting leads that have already gotten a jump start on what we need to have for the season. And so our first concern was basically counting game pieces scored, just because it's going to be such fast-paced gameplay. And so we're kind of looking at more like qualitative ways of measurement for scouting, like looking at, say, how many cycles they were able to get, and if they scored a lot of balls, or like if they look like they're pretty accurate. So we're working on tuning that in more, but we've got some really experienced and great people working on it, on our whole system for that this year. Okay,
cool. So you're not really looking at it from a big data perspective. You're not trying to get as much, just gobble up as much data as you can, but you're trying to take you're trying to leverage the experience you have and sort of use it better with the rest of your team.
Yeah.
Okay, that makes a lot of sense. Cool. So do you guys know how you're going to be collecting that data? Are you going to use like a paper sheets or an Excel sheet or a cool app on a phone or something? Or
in past years, we found a lot of success with just solid paper scouting, and then a scouting meeting at the end of each night to consolidate all the data. So yeah, I think we're going to do paper scouting in the stands and then compile all that for our pick list.
Okay, cool. That makes a lot of sense. All right. So by the way, if anybody has any questions for Cybertooth, you're welcome to send them in by typing !Q, followed by the question in the Twitch chat. And if we like your question, we'll ask them to him live on air. So I think we're going to start off by asking a question in just a second. But again, if you've got more, send them on in. So I guess the next question for you guys, before we go to ask for the chat, is where do you guys think you are in the season? Do you think you're ahead of schedule? Do you think you're on schedule? Or do you think you're not on schedule? We'll say that in a positive way.
Well, I think that we're slightly behind schedule, but we're in a really good place where we're getting parts made, and we're still working on CAD, but we're getting the final touches in before we can really start going full-fledged into creating our robot. Yeah.
Mm-hmm.
Cool.
Yeah, most of our sub teams are doing pretty well. A couple of them are ahead, like our gear group and our rope climber group are both very well off where they're at. But then fuel group and drive team, which are our more important tasks, we've spent a little bit more time on just to make sure those are more perfected so that we can really get what we want out of this robot. So it's been paying off. Things have been going well with that. So
cool. Well, that's great. And I know that, like, I would say most teams are probably behind where they want to be. So, and it's good that you guys have a plan going forward to make sure everything ends up on time. So it's good to hear. All right, let's take our question from the crowd here. Question coming up first here is, all right, this is coming from Twitch chat. Why do you build two robots if you can only compete with one? This is a really good question that I think a lot of first people kind of take for granted. But don't you give us and the rest of the folks at home a little idea of why build a practice robot at all?
One of the really big reasons is driver practice. In past years, we found that leading up to if we have, say, a week 1 or week 2 event, we don't get enough practice in just because we're so pushed down to the wire. And so if we have that practice bot that's identical to the bot that we're using in competition, and the competition bot's already bagged, we can still practice and test things that we can implement at competition when we have open bag time.
Also, because we're making our practice robot first, we're able to perfect things and figure out what we're going to do more quickly. And even if, like, on our practice robot it's kind of messy, we'll have experience doing that, so that way it'll be perfected for our real robot.
Mm-hmm.
Oh, I hit the wrong button. That's almost like a beta test, basically, or a prototype before your real robot.
Yeah.
Mm-hmm.
Okay, cool. That makes a lot of sense. All right. Well, guys, thank you so much for joining me once again on Check-In. It was great to hear from you. Great to hear about your team. I can't wait to see where you guys are next week. Next up on Check-In is Team 2337. It's the Engine Nerds. They're from Michigan. They're going to be joining us here. We're going to take a very quick break and come right back. But for now, Cybertooth, thank you so much for joining us, and we hope you have a good week. Bye-bye.
Thanks for having us.
Thank you.